Good evening, everyone. Welcome to the homework portal. So now we are solving problems from past papers or maybe from textbooks or from online resources. Okay, now this is a problem which is based on rotation, and this question states something like an ancient Chinese clock manufacturer. The mechanism consists of a weight hanging from a rope around a cylinder. Okay, so I have a cylinder here and I have a rope here. There's a weight over here. What will happen? So this weight will now go down, and as a result of it, this cylinder will now start rotating like this. Okay, let us read the full problem. The rope slowly unwinds, driving the hands of the clock. Okay, so the rope slowly unwinds. The student tries to recreate the mechanism using a cylinder of mass 23 kg. So the mass of 23 kg and radius 4.2 centimeter. Okay, let me write down this mass is equal to 23 kg, really huge one, and this is equal to 4.2 centimeters, and a hanging weight of mass 1 gram. Hanging weight of mass 1 gram. So this weight is 1 gram. Wow, this is very small, and this is really high, larger. But still, because of gravity, this will definitely pull this one and will slowly start rotating. The arrangement is shown below. The moment of inertia of a cylinder of mass m and radius is given over here. Show that the acceleration of the hanging weight can be expressed as k times t, where t is the tension in the rope and k is the constant. So how do we do this? The best way is in rotation. We need to start with a free body diagram. Now, how do you start with the free body diagram? Now, what will happen here? See, why is this rotating? This is rotating because this mass is pulling, right? When this is pulling, T is rotating. T is pulling like this, and as a result of it, it rotates like this over here, right? So therefore, what I get right is that I can say this is my radius r. I can now write T into r is equal to, what is T into r? T into r is nothing but torque, right? Torque is equal to I into alpha, moment of inertia multiplied by angular acceleration, which I already learnt about here, right? Now what we will do is, I'll just keep this one as such, and I, what's the value of I? It's already given here, half mr square. Okay, let me substitute it over here. So mr square divided by 2, and since this is not slipping, the thread is not slipping, so I can write alpha is equal to a divided by r. So this r and this r goes away, and there's one more r here, this r and this r goes away. That's what I get here. I write T is equal to ma divided by 2. If you solve it, you will get to know clearly. Now what is being asked over here is asking express the acceleration of the hanging weight to be k times t. Okay, so now what I can do is I can now write a is equal to 2t divided by m. I'll put 2 by m to be a constant. I'll write k times t over here. So we have proved. But the question that you will now ask is that, hey, you have got the value of a here, but how sure are you that this a is nothing but the acceleration that you have described here, right? Because that was the question here. See, what does it say? So that the acceleration of the hanging weight. Okay, he is asking about this hanging weight. Okay, how sure are you that the weight, that the a that I have put over here and the a that I calculate here, both are one and the same, right? So towards it, understand this part over here. So what is this a here? The linear acceleration. What is this linear acceleration? The acceleration of this point. Okay, how did I get this? I get this value by using a is equal to r alpha. What is alpha? Angular acceleration. So if something is rotating like this over here, then what did you get? You got the linear acceleration of this particular point. Now what is so special about this point? This point and this rope are tied together. If I say that the linear acceleration here is like this implies it's the same as the linear acceleration of the rope that is going downwards, right? So which is nothing but the same as the linear acceleration of the weight that is being hung over here. Okay, so therefore now these are one and the same. Thus we are able to prove that a is equal to kt. Now let us move on to the next one. Now the second question, determine the acceleration of the hanging weight. What is the acceleration of the hanging weight? Acceleration of the hanging weight is nothing but a itself. A itself. And what is that value? Which is equal to k multiplied by t. But we have already got a equal to kt here. But why am I putting this one here? If you ask me this question, then what I will do is I will write this as k. What's the value of k? K value is, we have got 2 by m. 2 divided by m multiplied by tension. But he says determine over here, which means what? I need a value here. Okay, I need numerical value. So how do I get a numerical value? M value is known. M value is 23, but I do not know the value of t over here, right? So I need to get the value of t. So how do I get that value? So what we do is, let me go back here. We have drawn only the free body diagram for the first one. For the second one, we have not drawn. What we will do is, let us take up this. Tension acts like this. For this object, let us draw the free body diagram. And then mg. Remember, this capital M and this small m are different. Okay, because that is 23 kg is 1 gram over here. You have to be very, very careful. Because some students, what they do is they put this capital M here and they do some mistake, and finally the entire equation goes wrong. So you have to be very careful here. So therefore, since it is moving downward like this over here, I can now write mg minus t is equal to mg. I can write like this. Now what do I have? What do I have here? I have, for the value of a, I need the value of a here, right? I already have t is equal to capital Ma by 2. So I will just substitute mg minus capital Ma by 2 is equal to small ma. Okay. So remember this. Otherwise, what will happen is you would have substituted this capital Ma here and you would have written 3 Ma by 2, which would be completely wrong. So I will write mg is equal to I made the same mistake. M by 2 plus m multiplied by a. Now what should I do? I should just substitute the values here. What is this now? This is 1 by 1000 because it's 1 gram over here, right? So I will write this as 10 divided by 1000. I will consider G to be 10. This should be 23 divided by 2 plus 1 by 1000 multiplied by a. Okay, most of us have a calculator, so I can easily calculate this value, and I will write this as 10 by 1000 is nothing but 0.01 is equal to 23 by 2. What will this value be? It will be 11.5 plus what will this be? 0.001 multiplied by a over here. The value of a would now be equal to 0.01 divided by 11.5 and 01. 11.501. Let us use our calculator. Show what is the exact value, right? Okay. Now I've got my calculator here. I get 0.01 divided by 11.501. When I do this, I get this as 8.69 something into 10 power minus 4. So what I will do is I will write this as is equal to 8.69 into 10 power minus 4. Now the question is, what is the unit here? Meter per second square. Okay, but how much unit? What is the significant figures I should put? See, look at this value here. See, this is around 23 kg, 4.2 centimeter, 1.0 gram. So everywhere there are only two significant figures. So I will also use only two significant figures, which means I will write this as 8.7 into 10 to the power of minus 4 meter per second square. Okay, so we have done this also. This is also done. Calculate how long it takes for the weight to fall through a distance of 2 meters. Now, how do you calculate this one here? So now what do you see here? So this object is now falling down, but how much time does it take? So you can easily use S equal to ut plus half at squared. Hey, how do I use this? If you ask me this question, then the answer here is that, see, the acceleration that we calculated here is a constant, right? So therefore, definitely I can use it. Whenever the acceleration is a constant, what can I do? I can always use equations of motion, right? I can use equations of motion. So what is the value of u? 0 plus half into the value of a is already known to me, 8.7 into 10 to the power of minus 4 into t square. Is the value of t square known? No, I do not know the value of t square. And t square is not known. What is known? S value is known. What's the value of S? S is 2 meters over here. I will write here as 2 over here. So I can say 2 is equal to 8.7 divided by 2 multiplied by 10 to the power of minus 4 into t square. Cross multiply this. T square will now be equal to 2 into 2 becomes 4. 4 divided by 8.7 into 10 to the power of minus 4. Okay, which should be 4 divided by 8.7 into 10 to the power of plus 4. I prefer to first simplify it and then proceed with the calculations, and which implies P will be equal to square root of 4 by 8.7 multiplied by 10 power 4 square root. If I take this becomes 10 square root. Okay, now let me calculate this value. What do I get here? I get this as 4 divided by 8.7. Let us do that. 4 divided by 8.7 will give me this value, and if I take the square root of this, I get 0.67. Okay, so I get this 0.67 into 10 square, which is around 67 seconds, more than a minute, right? This is what we get. Okay, next. So this is also done. Let us look at this one. Calculate how many rotations does the cylinder make in this time. How many rotations does it make in one in this particular time? So how do we solve this particular problem? Okay, I don't have space. Do one thing, I'll just erase this, and then let me do this. Just calculate the number of rotations. Okay, now let us begin with this. So how many rotations? Now what I will do is, to understand this, I will put it like this. So this was the cylinder, and this was the rope initially, which was hanging like this. Now what happened after some time? So this one now came back to here. It fell over here, and this is what it happened. It was with pulley over here. Okay, now as a result of it, it has traveled a distance of 2 meters. Now what I will do is, now I will start from here. I'll write the same thing here. Now let us say I'll write it like this. Initially, this was the point. I'll write it horizontally to make it more clear. Okay. Then later on, when this was pulled, what would have happened? So this would have been gone until here, right? So which is equivalent to, let us consider this particular point. If I take this pulley and put it over to this point here, maybe sorry, this point here, then if I roll this one here, like this, if I keep on rolling like this, let us say from here to here, okay, it has completely gone through one revolution. Let me ask you, okay, from here to here, there would be 2 revolutions. Here to here, I do not know how many revolutions it has happened. Okay, let me take some value. Okay, 3 revolutions, 4 revolutions. Okay, I have just given some example over here. Okay, so therefore, let me assume when I roll this pulley like this, I would have achieved this complete path, which means if I had rolled this pulley n times, I would have come to this point, right? Instead of showing it vertically, I am showing it horizontally over here. So which means this n times, if I roll this pulley full one, so for example, if I take this one, okay, if I take this particular point, as you see here, this particular point, if I roll this one fully, one full circle, what is the distance traveled by this? 2 pi r, right? Where r is the radius of this particular barrel. So therefore, I can now say n times I have rotated, multiplied by 2 pi times r. What is r here? R is the radius of the barrel. Which barrel are we talking here? The cylinder that we have here, right? The cylinder that we have should now be equal to the distance the thread has been moved about, right? What is the distance the thread has been moved about? 2 meters over here. 2 meters over here. So n should now be equal to, what's the value of r? What's the value of r? Value of r is, I wrote it somewhere, 42 centimeters, right? Am I correct? No, sorry, not 40, 4.2 centimeters. This is what happens when we do not write properly. Okay, now let us take up this. So therefore, this should be 2 divided by 2 pi into 4.2 into 10 to the power of minus 2. I'll write like this. So this will now give rise to, let us find out using our calculator. This will be, so 2 ones are, and 2 ones are, goes away here. Let me put up once again. So this would be 1 divided by pi. Do we have a pi here? No, 1. Oh, wait a second. Okay. 3.14 multiplied by 4.2 is what you get. 13.188. I'll take the reciprocal of this. I get the answer as 0.0758. Okay, I get that 0.0758 multiplied by, see, I have taken only this pi multiplied by 4.2. Okay, and this 10 power minus, so I'll pull it upwards. When I pull it upwards, I get this as 10 square, which I can now write this as 127.58. And what is the unit over here? What is that we are determining? The value of n here. See, 7.58. What is the unit? It is rotation, right? Which means it undergoes a 7.5 rotation. Okay, so you can either say 7.5 rotations directly over here. You can say 7.5 rotations, or you can say it is 7 plus rotation. Okay, both of them are equally valid. Don't put 7 rotations or 8 rotations. Both of them are incorrect. So therefore, it is 7.58. You can just say 7.5. 7.5 would be more precise because we are using two significant figures. We can say 7.5. If you want to round it up, you can put the 7.6 rotation. Okay. So with this, we complete one problem on rotation.